Okay, today what we're going to have a look at is probably the hardest criteria in problem solving and modeling tasks to do well in, and that's the evaluate and verify criteria. With these criteria, what I tend to find with students is it is often left to the last minute and the thought and planning hasn't gone into this criteria, or it is an afterthought. Students tend to stick to just statements rather than getting into the maths. Students will do individual bullet points and separate, evaluate and verify into a number of separate things as opposed to one big part of a whole problem solving process. And so it's a really new type of thinking, and it challenges students, especially in the area of maths when you're so used to answers being either right or wrong. Okay, so what we're going to do is we'll address these top two criteria here, see what the differences between them are, and about how we can best approach our task to ensure from the beginning how we can really set ourselves up to a good evaluation and verification of our results. All right, so we'll start with a sample task. And so if I'm looking at this sample task, you may have done this as a Fermi question in class at some point. You may have had a discussion with a teacher, but essentially what we're looking at is a task that doesn't necessarily have an answer, but what it does have is it has a reasonable answer we can develop based on some initial thoughts. So how many times can someone say the alphabet in one day? All right, not many people would sit there for a day, 24 hours, and say the alphabet over and over again and have another person tally, or they tally how many times they've said it. So we're going to use mathematics to try and see if we can come up with a good response. So the first thing you would have done, now this is not the point of this task, but the first thing you would have done is you would have done assumptions. Now really these are things that you are going to consider to be true so that you can develop a response. We can have different assumptions, we can make different assumptions, and that will change our outcome. But usually these are simplifications or conditions that we're going to put forward to say, okay, well, I want to develop a response. I'm going to assume these are true and develop my response assuming that these are true. All right, so if our assumptions are the recorded times for saying the alphabet will reflect the speed of the times for that can be said in that whole day. So how you start will be the same as how you finish. During a 24-hour period, there'll be no rest breaks. The times achieved from extrapolating the average time it takes to say the alphabet once. So we're going to find it. We're going to get an answer for the amount of time for one saying of the alphabet or reciting of the alphabet, and then extend that out to a full day. And then if we make three, and we're going to assume that three separate attempts of timing will, and then averaging will gain a representation for how long it takes to say the alphabet. Also some observations. Now this one's a bit light on when it comes to observations. Usually you'll be collecting some sort of physical situation, or you'll have something concrete to really grab onto. So this specific task is quite weak in our observations, so it won't necessarily form the basis of our evaluation later on, but it's worth mentioning some of them anyway. We'll get an answer for this soon enough, but the average time it takes to say the alphabet, might be somewhere between 5 and 10 seconds, but we'll have a look at that and we'll do some solving around that. We have an observation that there are 86,400 seconds in a day, and that if we are saying this alphabet, we need to be saying all letters of the alphabet and then clearly stated. All right, so if we're going to develop a solution, all right, so we're going to have an attempt with the conditions that we've done. So remember, we need to do this in 3 separate attempts. And we're going to time these ones and we're going to average them out, and then we're going to extrapolate this out to see what happens during a 24-hour period if there are no rest breaks. So there are conditions that we're going to work under. All right, so we'll bring up a stopwatch. All right, so we'll actually act this out. Sorry if it's a little bit boring. We're only going to do it 3 times. It shouldn't take us too long. So ready? A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. All right, so our first time is 6.85 seconds. I'll reset that, start again. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. Third attempt. We're ready, reset that. So A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. All right, so we have those 3 times, and we get ourselves an average for those 3 times. So we add the 3 up together, and then we divide that by 3, and we get an average of 6.49 seconds per attempt. If we want the total number of attempts, we're going to see how many times that fits in the full day. And now remember, our observation was there's 86,400 seconds in a day, which is just 24 times 60 times 60. So that divided by 6.49. So 86,400 divided by that is 13,319.63. Now, 0.63 is not going to be a complete saying of the alphabet, so we're going to have 13,319 attempts per day, or attempts of saying the alphabet in one day. All right, so that's our solution that we've developed, and now we're going to, that solution, we're going to have evaluate that solution, verify, we're going to see how reasonable that solution is. All right, so if we're going to evaluate this effectively, what we really need to look at is the difference in the 2 criteria. Now, you'll see in these first ones is this keyword here, statements versus evaluation. We'll talk later also about documentation and justification, but looking at what these statements mean and what it means to make statements as opposed to getting in more detail with documentation and so on. All right, so statements of the reasonableness of our solution. Now, you may have thought some of my ideas or my initial conditions might not have necessarily been the best as I developed my solution, and some of these might be some of the things you thought of. And these are the usual things students will put forward when they're actually talking about how reasonable their solution is. The answer will be too high because fatigue will set in, so won't be 13,000. There'll actually be fewer than that because someone's going to get tired and they won't be able to keep maintaining that speed. We could also have the answer is too low because the alphabet can be said faster. So people might have said that, notice that I did say L-M-N-O-P very clearly, but it might say L-M-N-O-P. You could hear all the letters in there, and I know that I said that it needed to be clearly stated, but you can clearly hear all those letters, so it can be said faster. So it's possible that that may be the case, or the answer isn't reasonable because variations will have some faster and some slower, and then we, across 24 hours, when we extrapolate that time, those fluctuations may be exacerbated, and we may be a long way out with our answer. So those basically are just statements. I went in a little bit more detail as I was explaining, but those ones are just statements. You can see that I haven't I've addressed the results, but I haven't really addressed the assumptions or the observations. All right, so that's a key important difference between them. And I've only really made statements. I haven't done evaluations. So what I suggest, and I'm going to make this video into a couple of parts, but what I would suggest there is when you're doing your evaluation, you need to really understand what evaluation means. So from our evaluation, you can read this yourself, but you're really going to be looking at the strengths of your answers, the implications and limitations in your methods. You're looking at your solutions, but we're really going to look at those solutions, those methods, those ideas you had, and see how they measure up against a set of criteria. And this is my big key that I really strongly push across to you, that having a set criteria will really hone your ability to evaluate. So determine the purpose, or when we're talking about the process of our evaluating, if you determine the purpose and criteria for this evaluation, what you're going to be by default is you're going to really, you'll see this, you'll really focus the way that you're going to be evaluating. You'll be moving past statements. You'll be trying to justify your answers a little bit more. All right, so we're going to develop some criteria, and that'll be the end of this first part. And then from there, we'll take it a little bit deeper. So developing criteria is the thing that I would recommend first. So I'm going to come up with some very simple criteria. So the criteria I'm going to judge on is I'm going to look at my method, and I'm going to see were my methods the most accurate or as accurate as they could be. That's a very interesting question. We challenged some of the thinking when we talked about our statements back here. We talked about our statements just here. These ones are challenging that the accuracy of our solutions, but they're not actually going into any detail. They're just making a statement. So when I'm really getting into my evaluate, I need to have my criteria. So that'll be my first one. And then I'm going to also have the criteria to judge on to see if my solution is realistic. All right, so does this, would this equate to real life? All right, by doing this, what you're going to, by default, doing is is my equation realistic? Well, I don't know if it's necessarily realistic to have no rest breaks. And by addressing that criteria, you're going straight back to your assumptions. And so therefore, you're really hitting this high bullet point that considers the assumptions. Is my method realistic? Is it realistic or is this my method accurate? Well, looking at it, if we go and average across 3 separate attempts, I would question that that's not necessarily accurate. So I've also now actually looked at the accuracy of my method and saying that 3 attempts might not have been the best to determine an average from. So that criteria alone has allowed me to go straight back to my assumptions. Also, I would say my solution being realistic. Yes, I mentioned that here with no rest breaks. That's not, I don't think that's very realistic. And there is, there's a problem with the realism there around 3 separate attempts being what it would be like across hundreds, maybe thousands of attempts across a 24-hour period. Yeah, so having that criteria, I think, is a very good first step. That I'm going to judge my solution based on these criteria. I'm going to look at my methods. I'm going to look at my solution, and you really then be starting to focus on your assumptions and your observations as well. Not that we said, remember at the start I said these observations aren't necessarily best because my task doesn't have a lot of facts that I'm pulling from different places to develop my solution. All right, so I'll leave that video there. This is part A. There might be another 1 or 2 parts to this video depending on how much detail we get into and how much information I can get across to you as clearly as I can. So I'll talk to you again soon, and thank you.